All right, Algebra 3 students, wanted to give you a quick tour of the classroom. Here's what it looks like. Got our smart board up here, all of your student desk right here, the teacher desk back here. The biggest thing I noticed about this classroom is it just feels so empty right now. So, I'm really hopeful that you'll be able to come in here eventually and get to do some things face to face. Here's my little makeshift studio I set up for today. I know it's pretty lo-fi, but it should get the job done. And you will want your own piece of paper today. Also, a calculator would be helpful. Today we're going to take what we learned yesterday about writing using set notation, and we're going to apply it today. We're going to apply it, and this will also serve as a bit of a review. The goal for today is to be able to write solutions using set notation. So we're going to review how to solve various types of equations and inequalities, and then we will, in each of these problems, we will write our final answer, our final solution, using what we learned yesterday, set notation. So go ahead and write down this first example here, and hopefully this is just a quick review. When you're solving an equation, a couple rules that apply. First, remember the concept of combining like terms. A term that has an x in it is called a linear term, or a term that has a variable is called a linear term. We can combine this 8x plus this 2x because they both have the x. They're both called linear terms. We can add these together into a 10x. Now this 12 here is called a constant term. It doesn't have a variable. So it's constant. It's always going to be 12 no matter what. This minus 12 is constant, so it's not allowed to combine with the linear term. We have to write it separately. Now over here on the right-hand side of the equation, we only have one linear term. It has nothing to combine with, but we have two constant terms. Now this 20 has a minus sign to the left, a subtraction sign to the left of it. I'm going to think of this as a negative 20 plus 2, and that comes out to negative 18. I'm going to write minus 18. Now another concept you need to solve a linear equation, I like to call it balancing an equation, meaning now we need to get our linear terms to combine together on one side of the equal sign and our constant terms on the other. So I'm going to actually remove this linear term. I'm going to take the linear term away from the right by subtracting it away, doing its opposite. Now, there's a thing in algebra called the golden rule of algebra that says you can do anything you want to the right-hand side of an equal sign, an equation, as long as you also do it to the left-hand side of the equal sign. So since I subtracted 7x from the right, I need to also do it from the left. That leaves me with the 3x. Now likewise, this is a minus 12. I'm going to make it vanish by doing the opposite, by adding it away. And the golden rule of algebra says I can add 12 to the left of an equal sign as long as I also add 12 to the right. Negative 18 plus 12 equals negative 6. Okay, now to solve for x, this 3 is called the coefficient of x. This 3 is being multiplied by x. So I can divide that 3 away as long as I also divide the right-hand side by 3. And I'm left with x is equal to negative 2. Now, negative 2 is the only solution to this equation. This is the only value of x. This is the only number, negative 2 is the only number that you could plug in for x into all of my x's, and it would make the left-hand side equal to the right-hand side. Now, the way that we can show this solution, in some cases, in some classes, in some circumstances, you'd just be able to circle this as your answer, and that'd be fine. But today we're practicing set notation. We're going to write our solution as a set. And this means not only is negative 2 one of the answers, this means that negative 2 is the only answer. It is the only solution to this equation. All right, so let's look at this now. Now these symbols are called absolute value symbols. Go ahead and write this down on your paper as well. And so these are absolute value symbols. Now what that means, absolute value will take any number and it will turn it positive. So what that means is that there's actually two possible ways to make this equation true. So the one is pretty obvious. If we can make this 5x plus 3 inside the absolute value marks, if we can make it a positive 18, then we know that that the equation is going to be true, because the absolute value of positive 18 is positive 18. But there's a second possibility here. Another way that this equation could be true is if the 5x plus 3 were to equal negative 18, because we also know that the absolute value of negative 18 is equal to positive 18. So here we have this equation that is going to have two possible outcomes that will make it true, and we're just going to solve each one of these separately. So here to solve for x, I can subtract the 3 from both sides, and 5x is equal to 15. Divide both sides by the coefficient of 5, and one solution is that if x is equal to 3, if I take the absolute value of 5 times 3 plus 3, that's going to equal positive 18. But that's not the only solution here. Here we have this other option where this would also be true if 5x plus 3 equals negative 18. Now I'm going to solve this one separately. The steps are still the same. I'm going to subtract 3 from both sides. And I'm going to divide both sides by this coefficient of 5. But I actually get a relatively different answer, kind of a very uniquely different answer. The other solution is negative 4.2. You know, if you did if you did 5 times negative 4.2 plus 3, that would be the absolute value of negative 18, which would also equal positive 18. So here we have an equation that has these two solutions. Now, generally, when you write your solutions in a solution set, you want to go from least to greatest. So first, I'm going to write the least of these numbers, negative 4.2, and then I'm going to write the greater of these numbers, the 3. This is my solution set. Now, just to let you know, you could write this using the set builder notation, all values of x such that. It would look like, it just looks kind of clunky though. You'd say all values of x such that x equals negative 4.2 or x equals 3. You know, in this case, I think that this is acceptable. I think that just looks kind of clunky. I think it's just much simpler to write your solution set in this way. So problem number 3, I'm going to have you actually try this on your own. I'm going to have you pause the video here in a second, try this on your own, and then I'll tell you what the answer is. You can check and see how you did. I will give you one hint though. When you're solving an absolute value equation like this, the first step is you do need to isolate the absolute value by itself, meaning we need to subtract this 5 from both sides of the equation before we can go ahead and draw these two arrows for the two distinct possibilities. So at this time, go ahead and hit the pause button and give this a shot. Let's see if you get the correct two solutions and write your solutions as a set. Go ahead and hit pause. And hopefully you came up with these solutions where x is equal to 4 and x is equal to negative 3. Now remember, when we write our solutions as a set, we want to go from least to greatest. So here is my solution set. And when you write your solutions as a set, that means not only are these two of the answers, it actually means these are the only two answers. There is no other answer that will work other than negative 3 and 4. All right, let's move to a different problem than problem 4 here. So this is called an inequality. You'll notice that this problem does not have an equal sign. It has a greater than or equal to sign. Now, one thing about inequalities you can still solve just like you would an equation. Okay, I'm still going to remove this constant term from the left. I'm going to subtract 21 from both sides. And when I remove the constant term, the 21 from the left, I'm left with this linear term. Now, the 2y has a subtraction sign to its left, so I'm going to write that as a negative 2y. It's a negative number because it has a subtraction sign to its left. And then over here, I take 100 minus 21, and that is 79. So inequalities can be solved just the same as equations, with one exception. There's one kind of rule you have to follow with inequalities. And the rule is this. Anytime with an inequality, anytime you ever have to divide both sides of an inequality by a negative coefficient. So since this is a negative 2, I have to divide by negative 2. If you ever divide an inequality by a negative coefficient, the rule is that you have to flip the direction of the sign. This greater than sign is going to become a less than sign. Okay? So if you ever have to divide by a negative coefficient, that's when you'd flip the sign. Now, by the way, if this would have been a positive 2, the sign would have stayed the same. But because it's a negative 2, this sign gets flipped. Now, what does this mean? This means that this is an infinite set. There are infinitely many numbers that would make this inequality true. So if we plug the value of negative 39.5 in for y, it would make this inequality true. You would end up with 100 is greater than or equal to 100. But the same is also true of any value of y that's less than negative 39.5. So this would be numbers like negative 40, negative 41, negative 42, negative 43. This is an infinite set. And now the other thing that's kind of unique about this not only includes all of your integers, this would also include all of your fractions and decimals that you could possibly imagine. So like negative 39.6 would be a solution, negative 39.7. There's no way we could possibly, imagine trying to make a list where you write out all these different answers that would work and trying to include all of the decimals, and all of the fractions that would work. This list would go on forever. It would be infinitely large, and it's just impossible to try to create a list of all these numbers. What we're going to do, we're going to use our set builder notation. It's actually really simple. To write this as a set, we're going to say all values of y such that, and then we're literally just going to copy down the answer that we have here, such that y is any number less than or equal to negative 39.5. This creates this infinitely large set of all numbers that are negative 39.5 or smaller, or less, I should say. So here's how we would write this solution. So number 5 is another one that I'm going to ask you to try on your own. I'm sure you've learned about compound inequalities at some point, probably in Algebra 2. Let's see if you remember how to solve a compound inequality. Go ahead and, when I say pause, go ahead and press pause, give this one a shot, and when you unpause, I'll have the solution for you. We can take a look at how you did. Go ahead and pause. All right, let's see how you did on this. So the thing with the compound inequality, when I subtract this 7 from the middle, not only am I going to subtract the 7 from the right-hand side, I'm also have to do it from the left-hand side. So here I'm left with 5, here I'm left with 20, and then the same thing when I divide away this 2. When I divide away this 2, I have to do it from the right and also from the left. Now I'm left with this solution. Now what this actually means is that as long as x is any number between 2.5 and 10, then it's going to be a solution to this inequality. Now the way that we're going to write this with set builder notation is we're just going to say all values of x such that, and then we're literally just going to copy down this answer. This means x can be any number between 2.5 and 10. Now, this means the 2.5 is not included, and this means that the 10 is included because it has the bar underneath it. Now, so this is how we'll write our answer as a set. Now, sometimes students will say, hey, Mr. Klein, couldn't I write it like this? Couldn't I just write 3, 4, 5, 6, 7, 8, 9, 10? Isn't that saying the same thing? And that's a good thought. I understand why you would think that. This is actually incorrect. Because with inequalities, you never assume that you're only talking about whole numbers or integers with an inequality. With inequalities like this, you actually are also assuming it could be any decimal, fraction, irrational number, any possible number that falls between 2.5 and 10, including all these little decimals in between. Believe it or not, this is actually an infinite set. There's actually infinitely many decimals between any two integers. So believe it or not, this is actually an infinite set. All right, that leads us to the last set that we have here, quadratic equations. So quadratic equations are different because your variable, in this case x, one of your variables is going to have a square next to it. The squared is what makes it quadratic. I know you spend a lot of time solving these in Algebra 2, so I know this is going to be a good review for you. But the first thing I'll tell you about quadratic equations actually need to be equal to 0 for you to be able to solve them. So in this case, I'm actually going to subtract this 10 and remove it from the right-hand side and subtract it over to the left-hand side. And now this is called standard form. And you learn a lot of ways in Algebra 2 how to solve a quadratic equation. One way I'm going to review right now is called the quadratic formula. So I'm going to put a coefficient of 1 in front of this x squared. And what you can say is that a is equal to 1, b is equal to 3, c is equal to negative 10, just using these coefficients here. And quadratic equations always have two solutions. One way to find those solutions is through what's called the quadratic formula. Now let me use my magical powers, and voila, here is the quadratic formula written down for you. The idea is that I can take these coefficients 1, 3, and negative 10, plug them into this quadratic formula that you learned, definitely learned in Algebra 2, some of you maybe even Algebra 1. And it will give me the two solutions to this equation. Now I'm going to use my magical powers again, and voila, here all these numbers are filled into the formula. Now when you go to solve the quadratic formula, what I personally like to do, I like to start with this square root here, this 3 squared minus 4 times 1 times negative 10, and I like to work it out separately. 3 squared is 9. And then a subtraction sign. And then 4 times 1 times negative 10 is negative 40. Now, technically, this would read as 9 minus negative 40. Although, anytime you subtract a negative number, it's the same as adding them together. This is really just 9 plus 40. And the square root of 49 is 7. So what I do now is I take, and I'm going to go ahead and do this 2 times 1 here is just 2. So everything that was under this square root now has simplified to just 7. So I'm going to carry my 7 right here. And then here's the two solutions to this equation. First off, negative 3 plus 7 divided by 2. Okay, negative 3, and you have to do the numerator first. So negative 3 plus 7 is positive 4 divided by 2. Here is one of my solutions is positive 2. Now the other solution is going to be negative 3 minus 7. And I'm going to put that in parentheses because I have to do the numerator first. Negative 3 minus 7 is negative 10. And divide that by 2, I get negative 5. So here's my two solutions. I can write these in set notation. I'm going to put the least of these solutions first, negative 5, and the greater of these solutions last. This is my solution set. These are the two and only two solutions to this equation. I could plug a negative 5 in for x. I could do negative 5 squared plus 3 times negative 5, and it would equal 10. Remember, when you square a negative number, it comes out positive. And I could also do 2 squared plus 3 times 2, and it would also equal 10. So with that in mind, go ahead and give this last one a shot. This is the last check problem that I'm going to give you. I want you to try this first, and then as soon as you unpause, we're going to go over the answers and see how you did. So go ahead and pause and give this a shot. And here we go. The answers are, you get an answer of 6, another answer of 2. Write that as those solutions as a set. The set of solutions is the numbers 2 and 6. Now, quadratic formula is nice because the quadratic formula will solve any quadratic equation. I think it'd be good to remind you of a shortcut as well. There's a shortcut that works with some quadratic equations, particularly quadratic equations that don't have have an a value of 1 here. Some quadratic equations can be factored. It's kind of a shortcut you can use to solve them. If your leading coefficient here is a 1, if your a value is 1, what you can do is you can look for two numbers that add up to the coefficient of your linear term. So two numbers that add up to negative 8. And then look for that same pair of numbers would also have to multiply to positive 12. And those numbers are actually negative 6 and negative 2. Okay, if you do negative 6 plus negative 2, you get negative 8. If you do negative 6 times negative 2, you get positive 12. What you can do is you can factor this quadratic equation into x minus 6 and x minus 2. If you were to FOIL x minus 6 times x minus 2, you would get this as a result. And then what that means is now you can set each of these factors equal to 0. And you would get the same solutions. You would get one solution of x equals 6. You would get another solution of x equals 2. And so that's a handy shortcut that works some of the time, not all of the time. But hey, if that can save you a little bit of time in your assignment today, then that's a good review of that shortcut. Okay, if you're not too comfortable with that shortcut, by all means, when you get to your assignment, you can stick to your quadratic formula. Okay, so best of luck on your assignment now. Please don't hesitate to contact me if you have any questions, and good luck. Bye.